Welcome back to the deep dive. Today we are strapping in for what is maybe the most hyped and definitely the most contentious new piece of tech in AI right now.
Oh, absolutely.
We're talking about the launch and, well, the early reception of the new frontier model, Gemini 3.
It has been an absolute whirlwind.
Yeah.
The official hype, it suggests this seismic generational leap in cognitive power.
Right.
But then the immediate feedback from either the developers, the power users, the skeptical engineers on the forums, it's just coming in so hot and contradictory.
That is the perfect way to describe it, and that's exactly why we're doing this deep dive. We've got this massive stack of sources in front of us.
Everything from the official docs to Hacker News comments.
Exactly. Official docs claiming performance gains we've never seen, these genuinely mind-melting benchmark scores, and then the unfiltered, messy, real-world user reports.
And our mission today is to cut through all of that noise.
Yes. We're here to find the true nuggets of insight. What can this model really do? What are its bizarre, unexpected failures? And, what does this actually mean for you and the future of your work?
Well, we have to navigate this core tension. On one side, you have these claims of a step change, breakthrough, a fundamental improvement in reasoning.
And on the other?
On the other, you have this messy reality where the model is, as one of our sources so perfectly put it, so bad and so good at the same time.
That quote just nails it. Okay, that perfectly sets the stage. Let's start with the quantitative claims, because this is where the story of a real research breakthrough, not just more compute, really starts.
We have to, because the data here is, it's truly anomalous. When you look at the raw benchmark gains, especially in complex reasoning, the numbers just scream that something fundamental has shifted in the architecture.
So let's talk about math, because that's always been the Achilles heel for LLMs, right?
Always. They're just notorious for struggling with verifiable multi-step logic.
And that's what makes this Math Arena Apex score so significant.
It is. Gemini 3 scored 23.4% on that benchmark.
Okay, 23.4. Put that in context for us.
Well, for perspective, the models we thought were state-of-the-art just a moment ago, Gemini 2.5 Pro, it managed 0.5%.
0.5%? Wow.
Claude Sonnet 4.5 was at 1.6%. Even the highly optimized GPT 5.1 was only at 1%.
Wait, a 23-fold increase over the previous generation's best? I mean, that just seems unbelievable.
It does.
Shouldn't we be immediately skeptical that they just, gamed the test? Because that's what usually deepens, isn't it?
That's exactly the right question to ask. And the consensus within the research community is that Math Arena Apex is, well, it's designed to be notoriously difficult to game.
So this is probably real.
The thinking is that this massive leap suggests an underlying mechanical difference. It implies the model has moved fundamentally beyond just probabilistic token prediction.
So it's not just guessing the next word anymore.
It's not just statistical guessing. It's moving toward what we call verifiable search.
Verifiable search. Okay, so what is it doing instead?
So essentially, it's not just generating text. It's generating it based on this deliberate tree-like search process. It generates potential paths. It detects its own errors or contradictions early on.
And then it can backtrack.
It can backtrack, delete the bad path, and try a completely different direction.
So it's effectively acting like a much more powerful debugger for its own thoughts.
Precisely. And this capability, this internal error detection and search, that's the key insight. It lines up perfectly with what Demis Hassabis has been saying for years, that all intelligence is basically a big tree-like search process.
And if it can search and course correct that, well, its reliability on other things should change completely.
And it does. We see that reliability bump show up everywhere. Look at simple QA.
Right, that's the metric for cutting down on those confident-sounding fabrications, what we call hallucinations.
Exactly. And the simple QA reliability more than doubled what GPT 5.1 achieved. We're talking 72.1% versus 34.9%.
Wow.
That is the hard data behind the claims of a step change leap in reducing hallucinations. The model isn't just holding more facts, it's dramatically better at checking its own logic.
And this abstract reasoning power, it extends into multimodality too, right? Which is often much harder to game.
Absolutely. The breakout performance on visual reasoning tasks is the proof. Take ScreenSpot Pro, Gemini 3 hit 72.7%.
And GPT 5.1.
3.5%.
That's staggering.
It is. But the real litmus test for what we call fluid intelligence is RRC AGI 2.
The abstract reasoning corpus puzzles. For anyone listening who might not be familiar, why are these ARC puzzles such a high bar for LLMs?
because they test pure generalization, fluid intelligence.
Mhm.
The goal is to solve these novel, abstract spatial puzzles where the rules are only given to you visually.
So there's no text in the training data it can fall back on.
Exactly. Standard token prediction just fails. But Gemini 3 reached 31.1% on ARC-AGI-2 versus GPT 5.1 17.6.
So that's strong evidence that the underlying cognitive horsepower for abstract logic has just dramatically increased.
It is a remarkable display of raw, abstract intelligence, no question.
And that brings us to the great pivot, doesn't it?
It really does. Because that incredible, verifiable, abstract intelligence seems to just evaporate the second the model runs into messy, real-world problems.
It's back to that quote, so bad and so good at the same time.
It
It's
is.
almost comedic. It can solve an equation that would take a PhD mathematician days to crack.
But it fails on trivial niche facts.
Yes.
The shortcomings in just basic knowledge retrieval are so apparent. Despite the huge leaps in logic, these models still fail spectacularly on niche questions when they're offline, when they can't use a search engine.
Like that example someone mentioned.
Yeah, a user tested it by asking for the mayor of Londrina, a medium-sized city in Brazil. And all the frontier models, Gemini 3 included, they either made up a name or just got it flat out wrong.
It's the ultimate litmus test. Superhuman logic on a closed puzzle, but it can't tell you a simple civic fact if it's not mainstream.
And it shows that this verifiable search mechanism is amazing inside its own logical process. But if the initial knowledge it retrieves is flawed or incomplete,
It will just use its incredible logic to build a very convincing, very complex hallucination.
and we see that same frustration spill over into developer life too.
Yeah.
Programmers are reporting these little hiccups like failing a fairly basic Python benchmark.
For giving you totally made-up parameters for software.
Exactly. Convincing but completely hallucinated. They cited examples for the video player MPV or just getting non-functional YAML configurations for Home Assistant. The output looks professional, it looks right, but it just fails to execute.
That is the core danger, isn't it? A convincing hallucination. And yet, this is contrasted by these astonishing successes in pure transformation and boilerplate.
This is the good side of the paradox. We had that one anecdote about a user.
The legacy XML one.
Yes, he had this custom XML format for years and had to write a bespoke compiler to turn it into a web app. Gemini 3 did the same thing, generated the working web app from that custom XML in under a minute.
That story really says it all. It is incredible at transforming format A into format B.
It confirms the model is excellent at format transformation and boilerplate, which, some people argue is 90% of coding.
And the visual generation is just, it's next level.
Oh yeah, we saw that pelican riding a bicycle animation and that incredible, highly complex SVG fantasy mage tower.
Those SVG animations were genuinely magical. It showed this deep ability to turn a creative idea into complex working code.
It did, but the developers who appreciated the magic immediately pointed out the core problem with the code itself.
It's convoluted.
It's convoluted, it works, but it's incredibly hard for a human to improve or debug. It seems to prioritize getting a working result over, say, long-term maintainability.
So it can generate a masterpiece, but maintaining that masterpiece takes a huge amount of human effort to untangle its brilliant but clumsy logic.
Which brings us directly into the broader implications, and this kind of cultural drift we're starting to see as these tools become part of our professional lives.
Right. And the first major debate is around the benchmarks themselves. I mean, if the code is convoluted, what good are the scores?
Well, this contradiction between superhuman benchmarks and clumsy real-world output, it just fuels skepticism that these tests are becoming less meaningful.
Even if they aren't being directly gamed.
Right. When a model can ace Montharina Apex but fails on simple Home Assistant YAML, it tells you something. It's optimized for internal coherence, not necessarily real-world use. The wisdom now is you have to always curate your own out-of-sample benchmarks.
You have to test it on your own stuff. Speaking of internals, there was a curious detail about the model's training data.
Yes, that was interesting. The knowledge cutoff for Gemini 3 was listed as January 2025, which is the exact same cutoff as the previous version, Gemini 2.5.
That's very unusual for a major version bump.
It is. And it suggests that the massive cognitive leap wasn't from just pouring in new data. The breakthrough is entirely in the fine-tuning, the retrieval, and that verifiable search mechanism. It's about how they taught the model to use its knowledge, not how much it has.
That is a critical distinction. But moving past the technical side, we have to talk about the professional fallout, specifically this concern over language contamination.
This is a subtle but I think a really profound insight into how these tools are changing us.
You mean how our own writing starts to sound like an LLM?
Exactly. Users said they have to make a conscious effort to avoid mimicking some LLM patterns in their own professional writing.
What kind of patterns are we talking about?
It's this sort of insidious professional boilerplate, excessive hedging, overly formal jargon, a uniform rhythm that just lacks human personality. One source said, language is contagious.
And if you spend your day editing this statistically optimized text,
Your own prose starts to drift toward it. It's that old saying, if you gaze long into an abyss, the abyss also gazes into you. We are adapting our thinking and writing to the machine.
which has real consequences, and that leads us straight into the intense job debate in software development. We're seeing two very different views on job security right now.
On one hand, you have the high-risk scenario. Current LLMs can easily write, basic CRUD web apps, simple mobile games, big transformation tasks,
All the boilerplate.
all the boilerplate. This commoditizes the output of a lot of moderately skilled developers. And the sources suggest those people need to upskill fast into things like system architecture or
Oh.
get a new career.
But the safety cam has a strong counterpoint, right? It's about quality, not just quantity.
Absolutely. The other view is that AI won't replace good quality coders who know what needs scrutinizing, who build maintainable systems. AI just makes them more productive.
Because the code is still convoluted.
It's so convoluted, it needs a human to inject maintainability, security, real-world context.
And there's the accountability factor.
Crucially, in the enterprise world, someone still needs to sign off on the work. Corporations demand an actual throat to choke for accountability when things go wrong.
When that hallucinated MPV parameter breaks a critical system.
That accountability will always fall on the human professional.
Okay, we can't wrap this section without touching on the skepticism around Google's market messaging, specifically the claims about user numbers.
Right. There was a huge community pushback on the claim that AI overviews now have 2 billion users every month.
Users called that disingenuous.
They did. Because the reality is Google gets that number by just injecting the AI overview directly into search results. If you open a search, you're counted as a user, whether you wanted it or not.
One user called the 2 billion users 2 billion hostages, which is maybe a bit much, but it gets the frustration across.
It does, and I think it's an important insight. This deep dive shows this undeniable leap in raw computational thinking math, logic, but it coexists with this persistent clumsiness in real-world application instruction following.
So the battleground is shifting. It's not about raw power anymore. Gemini 3 is clearly a world leader there. The fight is now for reliable execution and trustworthiness.
That's it, exactly.
This is a system that can solve a math problem that would take a human days, but it struggles with basic facts and, as we saw, can't be trusted not to run a disastrous git restore command that wipes your work if you aren't paying close attention.
It's the ultimate paradox. Abstract brilliance, operational clumsiness.
So what does this all mean for you, the professional who's trying to navigate all this? If these models are moving toward verifiable search and logic, not just prediction, then the next great challenge won't be building more powerful core models.
No, it's going to be building better human-in-the-loop systems that can manage and correct the model's inevitable clumsy mistakes.
That's the critical knowledge gap to focus on.
The model writes the convoluted code, but you have to be the architect who scrutinizes the logic, who provides the real-world context, and who assumes the accountability.
If the LLM writes 90% of the boilerplate, what is that final 10% of critical systems thinking that only you can provide? That is the question we'll leave you to chew on until our next deep dive.